Hello, now we are going to look at the theorem of Pythagoras in some detail. And we'll start by defining what the theorem of Pythagoras is. Now, written out algebraically, it's just h squared is equal to a squared plus b squared. And this formula is on page 16 in the log tables. But we really do need to know this one by heart because of the way questions can be asked using it. But what does this mean, h squared is equal to a squared plus b squared? Well, it's a theorem that works for right angle triangles only. So one of the things we have to be careful about with Pythagoras is that we only try to use it when we have a right angle triangle. So I have my right angle triangle drawn in here, and we need to talk about how the sides are labeled. So I have this side here is A, this side here is B, and then this side is called H, and it's across from the right angle. It's also the longest side in the triangle, and H stands for hypotenuse. So in a right angle triangle, the hypotenuse is the side that is across from the right angle, and it's also the longest side. And it's very important to be able to identify the hypotenuse. So we have a theorem, Pythagoras' theorem, which only works for right angle triangles. And one of the really important things for using it is figuring out what this hypotenuse is in each question. What's going to be the hypotenuse? Well, it's going to be the longest side, and it's also the side across from the right angle. The reason it's so important to identify the hypotenuse is because it's the side that's off by itself here. The hypotenuse squared is equal to the other two sides squared and added together. And if we put A in here, we would end up messing up our equation. So we need to figure out what side is across from the right angle, what side is the longest side. Now, why does this relationship work? Well, the picture here may give an indication as to where this is going. It's about the areas of squares being the same, or adding up to be the same. If I take my right angle triangle and I use the side lengths of my right angle triangle to create squares. So I have my golden or yellow colored square here, which is the hypotenuse square. So its area would be h squared. The side length A would form a square of a squared area. The side B would form a square with area b squared. What Pythagoras' theorem says, where it comes from, is that the area of the hypotenuse square, the golden square, the outside here, is the same area as the other two squares' areas added together. So physically, if I made this out, if I drew this out on paper and cut out the pieces, so I have my golden square sitting on my table, and then I take my a squared and I put it down in the corner, and then I cut up my b squared and I sit it in, it will sit perfectly inside of h squared, the hypotenuse squared. So the area of this big square, h squared, is equal to, it's the same size as the area of a squared plus the area of b square. That's physically where the equation or the theorem comes from. So that is Pythagoras' theorem. That's where it comes from. And to say it out in English, which I think I already have, for a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. And importantly now, anytime we see a right angle triangle, and we're particularly talking about the sides of a right angle triangle, because this relationship is relating the sides in a right angle triangle, we are always going to say, could I use the Pythagoras theorem here? It's always going to be a tool in the back of our minds going forward, because it comes up in lots of problem solving contexts. It doesn't just come up as standalone questions like these two. So let's put this into practice so that we have a little bit more of a feel for it. I have a right angle triangle here. I can see a right angle symbol, and I have a triangle, and I'm asked to find C. Well, I'm relating the sides of a right angle triangle together. That means I think of Pythagoras. So I write down Pythagoras' theorem. And I say, well, what side is going to be h? Because that's a big important thing. The other two sides are interchangeable, because I could have a squared plus b squared or b squared plus a squared. It would work out to be the same number. So the order of a and b don't matter, but h very much does. So what is h? It's the side that is across from the right angle, or the longest side as well. And that in this case is going to be c. So h is going to be c. So c is the hypotenuse. So I have c squared, sub everything in brackets. The other two can go in either order. I can have 1 squared plus 2 squared, or 2 squared plus 1 squared. Then we just solve our equation. So we have c squared is equal to 1 by 1 is 1, 2 by 2 is 4. We have c squared is equal to, I have like terms here, so I add them together, and I get 5. Now I have c squared is equal to 5, and I want to find what c is, so what undoes a square root does. So I take the square root of both sides, I get c is equal to square root of 5. Now, square root of 5, when we put it in the calculator, does not work out to any nice number. There's no nice number that multiplies by itself to give 5. So sometimes we will leave our answer just underneath the square root. C is equal to root 5. And we call that surd form. So surd form is where we have our square root left in our answer. But sometimes we want our answer given to a decimal. So if we want it to say 2 decimal places, we'd have C would be equal to, when we put that in the calculator, 2.2360, so on. It just keeps going. That's why it doesn't work out nicely. And then say to 2 decimal places, C would be equal to 2.24. We have to round up. So that's the 2 decimal places. And because we are measuring a length, this is a physical length of the hypotenuse of this triangle. We say that we have C is equal to root 5 units, or C is equal to 2.24 units, because we are measuring in something. In this question, it didn't tell us what we are measuring in, but it must be 1 something, and then this is twice as big because it's 2 of the same thing. And this is root 5 of the same units. So we say units even if they don't give us the context of what the unit might be: meters, kilometers, centimeters, so on. So let's go on and practice our next one. We have a right angle triangle, and we're looking at the sides, and we have a side missing. So immediately we're thinking we could use Pythagoras. So we write down Pythagoras' theorem, and this is really important for getting our memory built up so that this is a tool that we can call on when we need it. That's why we always write down our formulae instead of simply subbing in by looking at it written down somewhere else. It's really important to always write it down so that it embeds it better in our long-term memory. So we have h squared is equal to a squared plus b squared. What is h, the big important one, our hypotenuse? Well, it's across from the right angle is 17 meters. So that's going to be 17, everything always goes in brackets, squared. So that's our hypotenuse. And then we may as well call a squared plus 15 squared. No point in having that cramped. So we square out our numbers, and we have 17 by 17 is 289 is equal to a squared. A by a is a squared plus 225. And now we want to get a by itself. Now we're just solving an equation. So I need to subtract 225 from both sides to get a squared by itself, to isolate the letter I am looking for. And I get 64 is equal to a squared. And then I need to take the square root of a squared to just get a, which is what I'm after. I want to get a is equal to a number. And when I do that, I get 8. So the square root of 64 is 8, because 8 by 8 is 64. And I know that that means a is equal to 8 meters. My units in this case were meters. Now, we can get different styles of questions that relate to Pythagoras. So these ones are very direct uses of them. We have an obvious right angle triangle, and we're just looking for sides. But we can also use the relationship in different ways. So we have a triangular lawn, that's our blue lines here, with semicircular flower beds, that's our semicircles here. So we're told that these are semicircles, and we're asked to find m. So m is the area of this one of the flower beds. Well, I know the area off of the sides of a right angle triangle, this area here must be equal to this area plus this area. Now I originally derived that with squares because that's the easiest thing to understand, but it turns out that it's true more generally. And we could get a question like this where we have to work that out. We could also be asked to find the dimensions of the lawn. So that is something that we can do as well. But just for finding m, we would have 25 pi, the area of, so that's h squared. Well, sorry. No, it's not. That's the area off of the hypotenuse. So it's the side that is related to h, but it is not h squared, would be equal to 9 pi plus m. The area of the side off of the hypotenuse would be equal to the sum of the areas off the other two sides. So long as these are all scaled, they're the same shape, just scaled by how long these sides are. It's the only constraint. So then rearranging this formula, we'd subtract 9 pi from both sides. Pi just moves around a little bit like a variable, though it is just the number 3.14 and the decimals keep going forever. So 16 pi is equal to m. So we can use Pythagoras in that way. In case we were asked for the dimensions, I will just point out, if you wanted to find the length of the hypotenuse here, you know that 25, so this is a separate question, 25 pi would be equal to pi or squared all over 2, because the area of a, or squared over 2, that's the area of a semicircle, and we could use that to find the radius and then double it. So working it through, you'd get hypotenuse was 10 root 2 units, and you could do the same for the other two sides. Now, is the triangle ABC right angled? Is it a right angle triangle? Well, in a right angle triangle, I know that the hypotenuse squared is equal to the sum of the other two sides squared. And I know that the hypotenuse must be the longest side. The most important thing about it, it's across from the right angle, but I also know it's the longest side. So h squared, in a right angle triangle, h squared must be equal to a squared plus b squared. The longest side squared must be equal to the other two sides squared added together. Well, the longest side in that triangle is 26. So that must be the potential hypotenuse. So is that going to work out that 26 squared is equal to 24 squared plus 10 squared? Does that work out? And when I work it down, I get 676 is equal to 676. That equality is true. That means that h squared is equal to a squared plus b squared. That means that ABC is a right angle triangle, because Pythagoras worked, and that only happens for right angle triangles. And finally, we get questions like this, where we have to think through several steps. So we have our triangles here. By implication, because this is a straight line, the baseline here is a straight line, that must also be a right angle. And I want to find x. Well, I can't find x directly because I don't know this side here. It's missing. I don't know what it is. But if I say, okay, I want to know that side so that I could use Pythagoras to get x squared is equal to y squared plus 3 squared. Now I need to find y. Well, if I look to my orange triangle, I can say, well, 2 squared would be equal to y squared plus 1 squared. That'll get me y, and then I can get x. So I have to be able to follow through, label what I would need to find in order to get what I want, and then I may need to find it first. So let's work this through. I need to find y first. So I have found y, and it is root 3, and I write that in on my diagram. So I labeled what I was looking for, and then I also went back to my diagram and I filled it in. Now I need to find x. Working that down, I get at x is equal to 2 root 3. Here I got root 12, and I noted that I could write that as 4 by 3. Square root of 4 is 2, so I get 2 root 3. I can also write that as 3.46 if I was asked for it to 2 decimal places. And that's what we need for now.